So this is the second lesson from Chapter 6 on calculus. So I think this warm-up's one that you should definitely try. I'll pause the video and then try these questions and then start the video up again. We're going to be using these skills, parallel and perpendicular lines, in this lesson. So it's a very important skill to make sure you can actually do. So when we're finding something that's parallel like this, it means it's got the same slope. So first of all, we need to find what is the slope of this line. Now, this is not in slope-intercept form. So if we rearrange this, we get y equals negative 2x plus 5. And then once it says y equals, we can find the slope just by looking here. So the slope for this is negative 2. Now, if we also have a point given to us, then we can use the point slope formula. So y minus y1 equals mx minus x1. And then we can simply plug in the values that we got. So this is my x1, this is my y1. So y minus 2 equals the slope, and as it's parallel, it's the same as this. X minus the x value. Now, as we're subtracting negative 3 here, I'm just going to go ahead and put plus 3. And I'm going to go ahead and multiply out here. So I'm going to distribute. So I've got negative 2x, take away 6. And then instead of subtracting 2, I'm going to add 2 to both sides. And I get negative 2x minus 4. I think that's probably the nicest form for that. Sometimes you want to put it back in the same form as the question as well. So we could also go back and say y plus 2x equals negative 4 as well, to make it look like the original form. Now when we get to question 2, slight change for this one. This one says perpendicular. So the key thing to remember about perpendicular slopes is that they're going to be negative reciprocals. So the slope for this one, actually this is in slope-intercept form already, so we can see that it's 3. Therefore the slope that we're going to use is going to be negative reciprocal of that, negative 1/3. We've got the point 6 negative 2 as well. And we're just going to use point slope formula again. So y minus the y value, so y take away negative 2 is just going to be y plus 2. Slope here is negative 1/3, x minus the x value, which is 6. It doesn't give us a form for this one. I don't like fractions particularly, so I'm going to multiply both sides by 3 here. And then now if I distribute this, 2 negatives are going to give me the positive. Actually, I can take away 2 of the 6's from both sides. I could bring this to the side possibly as well. So positive x plus 3y equals 0 would seem like a pretty good answer to start. So these are the skills that we're going to be looking for in Chapter 6. We want to calculate an approximation to the gradient at a point. And also we can give its equation. We want to calculate the exact gradient of a point on a quadratic curve and other curves, not very specific there. And then find the equation of a tangent and normal to a curve at a point. And that's specifically why we actually did the warm-up, and that's going to relate to parallel and perpendicular slopes. Now, at the very end of the last lesson, what we found out is that if we have a formula in the form y equals some number x raised to a power, then if we want to find the slope, which we're going to call dy by dx, the difference of the y values over the difference of the x values, just like y2 minus y1 over x2 minus x1, then what we do is we bring the n to the front, and n times a you can just write as an. Leave this alone, but you decrease the power by 1. Now, we didn't really look at many examples for that, so if we had something like this, then I'll bring the 3 to the front and multiply. So 3 times 5 is 15, x to the, decrease the power by 1, so in other words, 2. If I do the same for this one, bring the 2 to the front and multiply, so 7 times 2 is 14, x to the power of 1, and as it's just to the power of 1, we could just actually put x for that one. So that's the steps that we did, and once again, as you can see there for the answer, I did just leave it as 14x rather than 14x to the 1. Now we can make this more complicated, and I've put the rule up here so we can see this as we're doing this. When we've got questions like this, we want to make it look like this. So using our rules of exponents, x to the 2 on the bottom of the expression, we can write as 5x to the negative 2. Similarly, we can write this as 6x to the negative 1. So that's your first step on all of these types of questions. Now we can go ahead and use the rule. So we can bring the term to the front, the exponent to the front. 5 times negative 2 is negative 10. Decrease the power by 1, negative 3. Bring the negative 1 to the front and multiply. Negative 6 times negative 1 is positive 6, x to the negative 2. So we're just using that rule, and that's called differentiating, what we just did there. Now, on questions like this, we want to try and make it of the same form. So if our original question was in fraction form, we want to make our answer also be in fraction form. So what we're going to do here is we're going to differentiate. So bring the number to the front, and then we get -10, decrease the power by 1. Whoops, that's supposed to say -3. And we already did this one, bring that one to the front, and so on. So now we want to put this back. So the negative exponent we can bring to the bottom, and the same with this, x to the -2 we can also bring to the bottom. Now we're starting to get quite complicated. We've got our surds in here, or radicals, and we've got things with fractions, so we've got terms on the bottom. So we notice this is x squared, but it's also on the bottom of the fraction, so x to the -2. With it being a cube root, we've got x to the -2/3 there. With this just being simply on the bottom, this would be 8x to the -4. So same as before, rewrite as ax to the n first, and then we can differentiate. So bring the power to the front and multiply, so -12 times -2/3 is +8. Decrease the power by 1, which would be -5/3. Bring the power to the front and multiply, -8 times -4 is 32, and then decrease the power by 1 would give me -5. So that's our differentiating. Notice for this question also, I wrote the question slightly different as well. Instead of writing y, I actually put f of x. Now on this step here, I just rewrote, so I didn't change anything. But when I differentiated, notice I didn't put dy by dx this time. So when we differentiate a function of x, we put what we call f dash of x. Or if you're doing AP calculus, we call that f prime of x. So just a different way of writing that question. As we have differentiated now, I'd like it to look like the original question. So I'm going to start putting everything back here. So this is the 5th power, cube root, and it's on the bottom of the fraction. 5th power, and it's on the bottom. And try to do that each time, and I just put a little note here to remind people of what that's actually called. Whoops. Now there's also some very simple differentials we should be able to recognize as well. So if we've got 5x, in theory this is 5x to the power of 1. So when we differentiate, bring the power to the front and multiply, and then decrease the power by 1. So 1 times 5 is 5. X to the 0. Remember, anything to the power of 0 is just 1, so this is actually 5 times 1. So in other words, it's just 5. Now actually we didn't need to go to all that trouble because we knew this from our previous classes anyway. If I said what's the slope of 5x, it's just 5, it's just how many x's it is. So that rule still applies. Now if I have 7, technically this is 7x to the power of 0, with x to the 0 being 1, 7 times 1 is 7. Bring the power to the front. Decrease the power by 1, 0 times 7 is 0, and anything times 0 is 0. So the differential of any number is always going to be 0. Now that's actually not a surprise, because if I said find the slope of 5x plus 7, you would just say 5 anyway, which is actually what we did here. So don't forget to link it back into previous knowledge as well. So if you've done the Algebra 1 course, or also Algebra 2, and I said, what is the slope of 5x plus 7? You would say 5 straight away. So it's still the same idea, so don't overcomplicate simple questions. So let's look at an equation, y equals x cubed minus 4x. So you can see we've got a nice curved shape here. And last lesson we looked at tangents. The tangent is the one where the line just touches at one point. Now we have another word of vocabulary as well, which is the normal. And the normal is just perpendicular to the tangent. And that's actually why we had our little warm-up today. We needed to know the slopes of things that are parallel, but also things that are going to be perpendicular, which is where my normal came in. So that was why we did that little warm-up earlier. Now specifically, you might be asked to find the equation of a tangent at a given point, and this is sort of really what you want to think about. So this is, what information do you need if you want to write the equation of a line? Because that's what the tangent is, as you saw on the previous picture. So that should be the sort of thought process that's going through your head while you're doing this. So if you need to write the equation of a line, you need to know a slope, and you also need to know a point, so we can actually use point slope. So let's see if we can actually come ahead and work these things out. Now they gave us the x coordinates, but they didn't give us the y coordinate. So if we substitute 2 back into this formula, as I did here, then we've actually got the y value. Now, if you saw the previous graph, you would have seen that it's 2, 0 anyway, but you're not often given that graph. So we've got a point. We also need to find the slope. How do we find the slope? That's that differentiation. That's why we're doing this. So this is bringing the power to the front, decreasing the power by 1. So 3, bring it to the front, decrease the power by 1. Differential of 4x is just 4, as you saw in those easy examples earlier. Now we want to know the slope when x is 2. So we just plug 2 into this formula here. So 3 times 2 squared minus 4, and we got our slope. Now this comes back to what we're doing in chapter 1. We have a point, we have a slope, therefore we can use our point-slope formula. So y minus y1 equals mx minus x1, and then simply just substitute the numbers into that formula, and then you found yourself the equation of that tangent. Now, as we've already done the hard work for this, let's answer a similar question. What if I ask you, instead of tangent, I say normal? So that's the only difference. Now, it's the same information. You need a point, you need a slope. We already found the point. The slope this time, though, is, notice it's a normal, so it's perpendicular to the tangent. So if the slope of the tangent was 8, then the slope of the normal must be the negative reciprocal of that. So in other words, negative 1/8. And then it's the same idea. We have a point, we have a slope, and then we can go ahead and use our point-slope formula. So this little word at the start of the question is very important. We're going to find our slope by differentiating, but then it's just a case of, are we going to use that? And we are if it's the tangent, or do the negative reciprocal if it asks us for the normal.